So today we are talking about money. Now, a lot of patterns in money follow exponential growth patterns that we've been talking about right now. Specifically, the concept of interest. Interest is extra money that you have to pay on a loan, or sometimes it goes the other way as well. For example, if you have a bank account, you earn interest by leaving your money in that bank account. That is how the financial system works. Be very careful of interest because sometimes you can pay more in interest than you do for the initial price of something. I think you will find cases of that today. Now, the formula to calculate interest follows as such. P times 1 plus R is raised to the T. So let's go ahead and break down what each of those mean. P stands for principal. That's not the same kind of principal as Mr. McCloud. It has to do with the initial amount of money. So essentially what you can think of it as is P is really the money. Whatever the money is will be P. T is the time, usually measured in years. Most often you calculate interest in years. Sometimes you do it by month, but that is other cases. And R is the rate. Usually you will find an interest rate. Now, here's the thing to remember about the rate. It's usually going to be written as a percent, which is not actually a usable number. So we have to remember to turn our rate into a usable number. Two ways to do it. Remember, per cent. If you break apart the word, it literally means per means divide, and cent means 100. We'll talk more about that with an actual number. So let's go ahead and we will look at number 3. We'll start with number 3. I'll show an example of 1 and 2 once we have a good, solid example. Okay, you buy a house for $250,000. I could pause right there. Oh, look, I have already found the money, P. You choose to pay nothing upfront and finance the whole amount. The interest rate is 4.5%. If the length of the mortgage is 30 years, oh, that's time, how much do you really pay for the house? Well, our formula is P times 1 plus R raised to the T power. So let's go ahead and just fill in what we already know. P is going to be 250,000. One plus, we'll leave a gap for a second, and we'll put in 30 for our time. Now we have our interest rate of 4.5%. R is equal to 4.5%. Two ways to figure this out into a usable actual number. You can take the decimal place on 4.5 and move it 2 to the left, filling in a 0 there. Or you could go 4.5 per divided by 100 and write that in. Either will get you to where you need to be. From here, we just go ahead and type it into a calculator. Sorry, thought my calculator app was already open, but it was not. So we can just go ahead and type in 250,000 parentheses 1 plus 0.045. That is 4.5 divided by 100. And we'll raise it to the 30th power. You type it in just as such, you hit enter. There is your answer. Meaning, by the time you are done paying off your mortgage, you will have paid $936,000, 329 with 53 cents. So that is our answer. So 936, sorry, I need to go back to double check what it was. 329.53. Make sure you have your money sign. Just put a box around your answer. Meaning, by the time you're done paying your mortgage, you have basically paid $1 million. Number 4 is very similar to number 3. The only difference is instead of t being 30, t is 15. Let's go ahead and try number 1. Number 1 is a little silly in that it has kind of an interesting way of measuring time. Suppose one of your ancestors invested $500, oh look, there's our P, in 1800 for an account paying 4% interest compounded annually. So our R rate is 4%. Find the account balance in each of the following years. In 1850, now how many years have gone by from 1800 to 1850? So that means T in this case is 50 years. Similarly, T here is going to be 100, so on and so forth. So the formula for this particular case is going to be 500 times 1 plus 4 divided by 100 raised to the 50th, because that's how many years have gone between 1800 and 1850. We could type that into a calculator. I'm going to go ahead and do some math here. 4 divided by 100 will be 0.04. So then we can go over to our calculator and type in 500 times 1 plus 0.04 and raise that to the 50th power. Use your Xbox button there. So that means we'll have 3,553.34 cents. Be careful with your rounding, but I'm not going to be too picky about that last number. We're going to use similar formulas for the rest of them. Now, I want to talk about one more example. We're going to go ahead and flip over to the back. I want to look at number 5. Now, number 5 is very similar to all the other ones, only you'll notice that instead of appreciating, it's going to depreciate. Now, think about it. Is a new car worth as much as a used car? Used cars are worth much less than a new car. So that is called depreciation, meaning the price goes down. The formula is identical with one small change. The formula will be P times 1 minus R raised to the T. We'll use that for number 5. We'll also use it for number 8 because it's got the word depreciates in it. So let's go ahead and figure out what number 5 is. Our P is 24,000 times 1 minus R. Now our rate is 25 over 100 raised to the, our time is 4. We could figure out 25 divided by 100. That's going to be 0.25. You can type that into your calculator. So let's go ahead and type this in. 24,000. Just want to double check, make sure that number is right. 1 minus 0.25, close parentheses, raise that to the 4th power. Meaning our car is only going to be worth about $7,600 after 4 years. I want to just double check, make sure I get the cents right. Make sure you have the dollar sign. Go ahead and give number 8 a try and work your way through the rest of them. You'll notice on problems like, say, 6 and 7 that the t value is changing. But the other parts stay the same. As always, let me know if you have questions.